Okay, I'm starting this lesson by just showing you what these are. The derivatives of these three are cosine of x, negative sine of x, and tangent of x. Or sorry, tangent of x goes to secant squared x. Now, in your textbook you'll probably see some proofs of these and some questions on relating to these, but this is all you really have to know. This is, for some of you, this will be the annoying part of calculus where it's just memorization, but for others this is kind of relief because all you have to do is remember these three and you can figure out pretty much any of the rest of them. Although I'd recommend that you look in your textbook and find some of the others, or look up online and find all the trigonometric identities. But really, this is the kind of thing that computers are good for. You plug in something and it'll give you a derivative. Some of the questions in a lot of the questions actually on the AP exam will be dealing with how you actually set up a question, how you actually set up a derivative, and then or an integral, which is something we'll get to later, and how you can, as long as you set it up, that's what's important, and then you can use your calculator to solve it for you. But that said, let's take a look at something like an ordered derivative with sine of x, for example. So if we start out with sine of x, and we want to take the derivative of this, we'll call this the zero order. I'll write this out here. This is the zero order. The first order derivative is cosine of x, as per the rule we learned. Our second order derivative is going to be negative sine of x. Same thing, that's just a rule we know. Third order derivative is going to be negative cosine of x, because if you remember, this is a negative 1 out here, and we leave that out when we're taking the derivative. So we just went directly to sine x to cosine x as we did up here. So our next one, for the fourth order derivative, our negative 1 is going to be brought down again and multiplied by the new negative sine of x that we're making here. So this goes to plain old sine of x. And as you can see, we've come full circle here and returned to the zero order. In this cycle, we'll keep going on as long as we keep taking derivatives of sine of x or one of these terms. So this is kind of an example of the cycle that derivatives has with the trigonometric functions, and really what can be seen as a really annoying part of calculus is not too bad, because there's only so much complexity you can add to these, and as long as you know the power rule and the constant rule, what you do when you're adding things, like if you had sine x plus cosine x, if right now you could tell me that the derivative of this is found by splitting these up into two parts, the addition, and looking at them separately, like this, cosine x, cosine x plus negative sine x, which equals cosine x minus sine x. If you could show me something like this, that's all you really have to know right now, and that's all your textbook will make you deal with. We'll come back to trigonometric functions when we deal with some more complex applications of derivatives and some stuff with integrals like I mentioned. But for now, we can leave it at this, and this will get you through your homework. So thanks for watching, and in the next video I'll show you a really important part of derivatives called the chain rule. Thanks for watching, and see you later.